Welcome to the complete guide on blockchain interview questions. Today, we'll explore the fundamental concepts of distributed ledger technology that every blockchain professional should master. Our journey covers four essential pillars: consensus algorithms that enable network agreement, smart contracts that automate transactions, cryptocurrency as digital money, and decentralized applications that run on blockchain networks. Whether you're preparing for your first blockchain interview or advancing your career, these concepts form the foundation of modern blockchain technology. Blockchain is a distributed, immutable ledger that records transactions across multiple computers in a network. Think of it as a digital record book that's shared among many participants, where each entry is permanent and transparent. The core properties that make blockchain revolutionary include decentralization, meaning no single authority controls the network. Immutability ensures that once data is recorded, it cannot be altered. Transparency allows all participants to view transactions. Cryptographic security protects data integrity, and consensus mechanisms ensure all network participants agree on the state of the ledger. Consensus algorithms are the mechanisms that allow blockchain networks to agree on the truth without a central authority. The two primary types are proof of work and proof of stake. Proof of work, used by Bitcoin, requires miners to compete in solving cryptographic puzzles to validate transactions and create new blocks. This approach offers high security but is energy-intensive. Proof of stake, adopted by Ethereum 2.0, selects validators based on their stake in the network. This method is significantly more energy efficient, enables faster transactions, and reduces the computational resources required for network participation. Smart contracts are self-executing contracts with terms directly written into code. They automatically execute when predetermined conditions are met, eliminating the need for intermediaries like lawyers or banks. Once deployed on a blockchain, smart contracts run exactly as programmed without any possibility of downtime, censorship, fraud, or third-party interference. The example shows a simple Solidity contract with basic storage functionality. Smart contracts can store data, retrieve information, and perform calculations automatically. They form the backbone of decentralized finance, automated insurance claims, supply chain management, and countless other blockchain applications. Cryptocurrency is digital or virtual currency secured by cryptography, making it nearly impossible to counterfeit or double spend. Unlike traditional currencies controlled by central banks, cryptocurrencies operate on decentralized networks using blockchain technology. Key characteristics include decentralized control with no central authority, cryptographic security protecting against fraud, peer-to-peer transactions without intermediaries, and global accessibility. Popular examples include Bitcoin as the first cryptocurrency, Ethereum as a smart contract platform, Cardano using proof-of-stake consensus, and Polkadot enabling multiple blockchain networks to communicate and share information. Decentralized applications, or DApps, are applications that run on a decentralized network of computers rather than a single server. They use blockchain technology and smart contracts to operate without central control. Essential characteristics include open source code that anyone can inspect, decentralized storage across multiple nodes, token-based incentives for network participants, consensus mechanisms for decision-making, and no central authority controlling the application. Popular categories include decentralized finance with platforms like Uniswap and Compound, gaming applications like Axie Infinity and Decentraland, NFT marketplaces like OpenSea and SuperRare, and social platforms like Steemit and Minds. Understanding block structure is crucial for blockchain comprehension. Each block contains several key components. The block header contains metadata about the block, including timestamps and difficulty levels. The previous hash creates an immutable link to the preceding block, forming the chain structure. The Merkle root is a cryptographic hash representing all transactions in the block, enabling efficient verification. The timestamp records when the block was created, providing chronological ordering. The nonce is a number used in proof-of-work mining to find valid block hashes. Each block has a unique cryptographic hash that identifies it and ensures data integrity throughout the entire blockchain network. Mining is the process of creating new blocks and validating transactions in proof-of-work blockchains. The process follows 5 essential steps. First, miners collect pending transactions from the memory pool, selecting those with appropriate fees. Second, they create a Merkle root hash of all selected transactions. Third, miners find a nonce value that produces a valid hash meeting the network's difficulty requirements. Fourth, successful miners broadcast their new block to the entire network. Fifth, the network validates and accepts the block, adding it to the blockchain. The example algorithm demonstrates how miners repeatedly hash block data with different nonce values until finding one that produces a hash starting with the required number of zeros. Blockchain interviews typically cover both technical and conceptual questions. Technical questions include explaining the difference between proof-of-work and proof-of-stake consensus mechanisms, describing how Merkle trees organize and verify transaction data, discussing the blockchain trilemma of scalability, security, and decentralization, and understanding gas fees in Ethereum networks. Conceptual questions focus on how smart contracts ensure trust without intermediaries, what makes blockchain data immutable and tamper-resistant, the benefits and challenges of decentralization, and how cryptocurrencies maintain and derive their value in digital markets. Mastering blockchain fundamentals requires understanding 5 core concepts. Distributed ledger technology enables transparent, shared record-keeping across networks. Consensus mechanisms allow decentralized networks to agree on truth without central authority. Smart contract execution automates agreements and eliminates intermediaries. Cryptocurrency fundamentals cover digital money creation, transfer, and storage. Decentralized applications represent the future of software built on blockchain infrastructure. For interview success, understand real-world blockchain use cases and implementations. Practice explaining complex concepts in simple terms that non-technical stakeholders can grasp. Stay updated with latest blockchain developments and emerging trends. Be prepared to discuss scalability challenges and potential solutions. Good luck with your blockchain interviews.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.